Ini udah ya. Mic-nya, mungkin mic-nya ada. Kita buka dulu. 12 menit sesi itu 3 menit pertanyaan. Oke. Baik, kita ya. Sebelumnya, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today we will have a parallel session for ICTS conference. In this room, we will have the track is cybersecurity and infrastructure. So we will have several papers about these topics in cybersecurity and infrastructure. The first presenter is Adi Saputra with the paper entitled The Robustness of Machine Learning Models Using MLSecOps, a case study on delivery service forecasting. So, Adi Saputra, you have 12 minutes for presentation, and then we will continue to question and answer session. Please present your paper.
Okay. Thank you. Good evening, everyone. I will present about the robustness of machine learning model using MLSecOps, machine learning security operation, a case study on delivery service forecasting. Okay, next slide. Delivery service forecasting with random forest. Delivery service forecasting is key aspect of the modern delivery service operation that significantly contribute the optimization operation and enhancement customer satisfaction. Machine learning can assist in the predict the delivery time. Delivery service forecasting in e-commerce is crucial managing customer expectation and optimize operation. On-time forecasting ensure customer are the provide with accurate developer estimate, boosting the trust and satisfaction. This also add the business in resource allocation and inventory planning. Meanwhile, delay prediction enable the business to identify and mitigate potential delivery obstacle. Customer can be notified advance about delay, strengthen communication, and trust. A random forest they choose because the machine learning this accuracy, flexibility, reliability from the algorithm. Algorithm the effective the handle large data in diverse the feature, manage missing data and resist to overfitting. Random forest can be used for the both the classification and the regression. Provide the clear interpretation and identify important feature. This the parallel processing capability speed up training and the prediction. It's optimal for application. Is requiring quick and accurate prediction as well to model interpretation. Then, but random forest has the vulnerability to attack, such backdoor attack and the boundary attack. A backdoor attack is type adversarial attack that aim the poison the machine learning model during the training. So it's make incorrect prediction to certain input. The attacker can achieve the by adding manipulate data to the training, which cause the model to assert certain input and certain output. And the boundary attack, this is the type adversarial attack, the aim to trick machine learning model into making incorrect prediction by add small perturbation to input data. The perturbation is the typical so small interception to human eye, but it is large enough to fool the model. MLSecOps or machine learning security can improve the security machine learning model. One of the tool is adversarial robustness toolbox. Adversarial robustness toolbox, which is the open source, use the test to improve and the robustness machine learning. So again, adversarial attack. Adversarial attacks are the aim to manipulate or damage the machine learning model, such change the input, the data to produce incorrect the production. Adversarial robustness toolbox provide the tool and the technique that allow researcher and the practitioner to identify, mitigate, and the test the model to again adversarial attack. With the adversarial robustness toolbox, developer can improve the security and reliability of their models, minimize the potential risk of the attacks, and ensure that model perform well even difficult attack situation. MLSecOps, machine learning security operation, to integrate the principle of MLOps, MLOps, the machine learning operation, and the cybersecurity to create safe and efficient ecosystem for the development, deployment, maintenance, and machine learning, maintain machine learning model, and include automation machine learning pipeline. The optimization of the model performance and the implementation security control to maintain integrity, confidentiality data, and the model. Okay, next slide. Okay, I'm conduct experiment with adversarial robustness toolbox. Experiment with the adversarial robustness toolbox improve the robustness of random forest algorithm again boundary attacks and backdoor attack. You can see the flow chart, the random forest with boundary attacks. We will experiment it and continue the robust of the model against boundary attacks. The robust of the model against boundary attack. This we will applying the adversarial robustness toolbox. So far, it can to improve the robustness the model, and the result will be compared from the before and after model with or apply adversarial robustness toolbox. And the finally we conclude what achievement with adversarial robustness toolbox. Okay, next slide. This describe boundary and backdoor attacks. From the training data, the process backdoor attack is the during the training. Uh, uh, for the attacker can doing to the poisoning the data, and the boundary attack is the the attacker will be doing at the small perturbation and the create incorrect prediction. And in our experimental, the result, the accuracy will be decreased. Accuracy normal condition is 93.5%, and when the accuracy boundary attacks is decreased to 90. Sorry, the 50. Accuracy backdoor attack will be increased the 50.7%. Okay, next slide. This the adversarial robustness toolbox. When the experiment with our experimental, we're training data, and we do adversarial robustness toolbox. Actually, we conduct before the data this the training and before data conduct the backdoor attack and boundary attack. This actually adversarial robustness toolbox is uh, uh, adding the small noise to identify or uh, to um, to 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 identify the model and training data. Is when the backdoor data is you have the positioning data, the attacker can choose the manipulate or manipulate accuracy in the model. And the model when the boundary attack with the same attacker can choose the manipulate result from the model machine learning. And the accuracy normal condition is 93.5%. Accuracy boundary attack after we conduct effort robustness toolbox is increase again 90%, and accuracy backdoor attacks increase again to 93.7%. Okay, next slide. Yeah, this is a result from the backdoor attack. They conduct two experiment, backdoor attack and boundary attack. Boundary attacks, this before attack we see ROC curve is 0.93, and after backdoor attack condition, ROC curve decreased to be 0.50, and the ROC curve after robustness with adversarial robustness toolbox, ROC curve increase again to 0.93. Okay, this table condition comparison, condition normal condition with accuracy 93.5%, precision 9.7%, 90.7%, recall 97%, F1 score the 93.7%, and the backdoor attack condition accuracy decrease to the 50.7%, and precision 50.5%, and recall the 100%, and F1 score the 67%. And when the robust model machine increase again to the 93.7%. Okay, maybe next slide. This boundary attack to the ROC curve will be same, the similar. They will be same result. This ROC robustness is ROC curve 0.92, and the condition have the similarity result, but the robustness model only increase the robust model machine learning accuracy only 93%. Okay, next. Conclusion. Implementation of techniques such adversarial robustness toolbox in machine learning prove effective improvement robustness of machine learning model. The accuracy model forest decreased from the 93.5% to 50.5%, where is the backdoor attack and boundary attack. The accuracy random forest after applying adversarial robustness return again over 90% when there is backdoor attack and boundary attacks. Okay, next. Thank you for the my presentation. Thank you for the attention.
Okay, thank you for your presentation. Any question from the participant? No, okay. I have a question. How can we, or where should we put the adversarial robustness toolbox in the pipeline? I mean, should we put this toolbox after data preprocessing or before the training?
Actually, we do it before the training, after the pre-processing. So, because adversarial robustness toolbox is we will implement our will be to we build robustness to the before the training data. This so
Okay. Okay, thank you, Adi Saputra, for your presentation. Um, so the next presentation is from Alfia Salsabila Yustin. Alfia, I think, is present in the Zoom meeting. Yeah, so the title of the paper is Leveraging Smart City Solutions for Sustainable Development in Indonesia, Overcoming Challenges and Strategic Recommendation for National Progress. Alfia, please present your paper.
Thank you very much. Can I hear my voice clearly?
Yes.
Okay, thank you. Assalamualaikum, good afternoon. First of all, I would like to express my gratitude to the committee of the 14th International Conference on Information and Communication Technology and System, or ICTS 2023, for accepting our paper, and to the moderator for the time of the opportunity. Allow me to introduce myself. I'm Alfian Salzabila Yusin, Master Degree student in Electrical Engineering with a specialization in Telecommunication Management at the Universitas Indonesia. I have a privilege today to present our research with the title Leveraging Smart City Solutions for Sustainable Development in Indonesia, Overcoming Challenges and Strategic Recommendations for National Progress. And this paper has not been authored solely by myself, but also received substantial contribution from my team. Consequently, therefore, allow me to introduce the paper contributor as follows. The first one is Miss Tika Diskavati. The second author is Miss Regina Riantika. The third author is Alfia Sadabestin. And the fourth author is our dear lecturer, Mr. Jatun Aprian. And we're from Department of Electrical Engineering, Master of Electrical Engineering, majoring in Telecommunication Management from Universitas Indonesia. Without further ado, let's move to the outlines. The first topic is the introduction. The second one is the research method. The third topic is a result and discussion. The fourth is the conclusion. And the last one is the future study and recommendation from this paper. The first one is about the introduction. The background of this topic is related to the high population growth in Indonesia. However, population growth and density in Indonesia are unevenly distributed. As the evident from the following table, population density in Indonesia is concentrated in the city on the island of Java, particularly in the DKI Jakarta region. With a population density at the 2020, it's 15,907 people per square kilometers in 2020 and increasing to the 16,258 people per square kilometer in 2022. It indicates an addition about 1,000 people per square kilometer within a span of 2 years. It signified a rapid population migration to urban area, or we can call it urbanization. On the other hand, urbanization can lead to economic improvement for the population. But on the other hand, it can also give rise to issues in urban area, particularly in concerning capacity of the city itself. In facilitating the increasing population, it's essential to complement it with the development of better urban infrastructure to meet the needs. One of the approaches taken in the implementation of smart city concept in DKI Jakarta. Smart city adoption leverage digital technology to enhance the daily lives of Jakarta residents. One example of this implementation of the government integrating transportation facilities. Technology utilized include the Internet of Things, artificial intelligence, and many other technologies. However, in the process of implementing and adopting these technologies, there are undoubtedly challenges to be faced. To minimize the error in addressing this challenge, it is crucial to identify the priority challenge and determine mitigation solution. The government must take action by creating the regulation that can accommodate the interests of the government, stakeholder or industries, and the citizen in building the smart city. Therefore, research is needed to determine the priority issue of Jakarta smart cities and provide mitigation solution recommendation from the government, stakeholder industry, and the citizen community's perspective. These are the research methods that we use. The research methodology used here is qualitative analysis, and it follows the research flowchart shown in figure 1. It begins with a literature review to find out what aspect that makes city called smart city based on the some previous studies. This aspect becomes our parameter. Then we interview some people that represent three different viewpoints. The first one is from the government, the stakeholder industry, and the last one is from the citizen. This helps us to figure out which smart city aspects are the most important. We gather their opinions and use the model shown in figure 2 to rate the importance. Value from 1 to 9 means it's very not very urgent, 1 to 9. 10 to 19 is moderately urgent. 20 to 30 is highly urgent. Finally, we discuss and analyze the result to decide which smart city aspect should be top priority and what solution can help with that issues. These are the results after we did the literature study. There are some categories and barriers that we found. The first category is about big data analysis, and then about artificial intelligence or AI, and then developing country. In this case, we found the paper about the Nigeria, and the fourth one is lessons from successful smart cities. And then there's some findings too about the categories about people, governments, and the last one is about the energy management. These are the parameters that we have selected to present to the respondent for their assessment and mitigation recommendation. The first one is big data analytics. So the second one is artificial intelligence. The third one is energy management, and then government, stakeholder or private sector, citizen, and the security. These are the assessment results and the proposed solution from the respondents. The first one is about the big data analytics. The result of the assessment, the level of urgency is high, and the proposed solution is first is upgrade enable technology and regulate data protection. The second one is integrating data from different sources. The second parameter is AI, artificial intelligence, and the assessment result, the level of urgency is high. The proposed solution, the first one is to regulate supporting local AI market growth. Second, facilitate collaboration between public and private sector, academia, and research institution. The last one is to invest the necessary infrastructure to support AI implementation in smart cities. The third parameter is about energy management, and the result of assessment, the urgency level is medium, and the proposed solution is regulation supporting the development of the smart energy. And then the parameters about the government, the assessment level urgency is resulting in high urgency level. The proposed solution is policy and legislation to support stakeholders and citizens and help to sustainability. Second one is initiate pilot project and demonstrate to test smart city technology in real world setting. And the last one is involve citizen and decision making and seeking public input on implementing smart cities. About the stakeholder parameters, the final assessment result, the level of urgency is high. The proposed solution, the first one is building infrastructure and develop adopting enabler technologies. Second one is invest in research and development efforts to explore innovative solution and technology that can enhance the functioning of smart cities. Actively participate in the development of policies and regulation related to the smart city implementation, and regularly evaluate and performance and impact of smart city initiative. And then the parameters about the citizens, the urgency level is medium. The proposed solution is first one, actively provide feedback on existing service and infrastructure. Then embrace the adopt and adopt the technology and service provided by smart cities and continuously improve the digital literacy skills to navigate and utilize smart city technology effectively. And the last parameters is about the security. And the one and only proposed solution is about the regulation from the government. These are the summarized results and comparison of the urgency level of smart city parameters. Parameters like big data analytics, governance, stakeholder roles, and security in the smart city system are considered to have a high urgency level. On the other hand, parameters like AI implementation, community resource management, and energy management are categorized as moderately urgent. We also discuss some possible solutions that government can consider when creating regulation related to this matter. And then this is the conclusion of this research. The first one, in order to make the regulation about smart city, we have to boosting citizen and private sector involvement alongside the government in smart city implementation for increased participation, innovation, and sustainability in managing smart city. The second one is in order to make a regulation, regulation itself has to align with the needs of Indonesian people, involving the government, stakeholders, and community in shaping the direction of smart city development in Indonesia, and using smart city service evaluation to inform the regulation smart city development in Indonesia. And then this is the last topic about the future study recommendation. So after we did the research, we have some recommendations for future study. The first one is the future research could add more smart city parameters. So the future research can add more parameters to be concerned that maybe have a different kind of urgencies in different cities. And then future study can incorporate a more extensive and focused range of perspective and studies for more specific respondents. Maybe in future study can be choose respondent that have maybe only on the productive age or maybe on the elders like that. And this is the last slide. That's all I have to say. Thank you for your time and attention, everyone. I'll now hand it back to the moderator for the next session. Thank you very much.
Question. So we understand that we have several parameters for smart city, like you described before. So what is your main recommendation to encourage the government to adopt the smart city approach for national progress? What is the main recommendations?
Okay, thank you so much for the question. So the main recommendation for governments, if we take a look on this data, after we ask to three different perspective of view, we got the data that things that have high level of urgency is big data, government, stakeholders, and security. So we have to concern about this top four topics about the smart city. It's also connected with the regulation that we have to make about the security. Thankfully, government already had a PDP regulation to secure the data of the citizen. But in big data analysis and government stakeholders, it still have to we have to ask government to formulate another recommendation in regulation. I think that's answered the question.
Okay, thank you, Via, for your presentation.
Thank you very much.
Thank you. Okay, let's continue to the next presentation. The next presentation is from Valerie Olive Suryono. The paper, she will present the paper entitled Design and Analysis of Fiber in the Building for Smart Building in Student Center di Universitas Indonesia. Yeah. Valerie, are you ready to present your paper?
Yes, thank you. Am I supposed to be the one that's sharing the presentation? Oh, ada LO-nya. Okay. Good afternoon, esteemed ladies and gentlemen, fellow scholars whom I dearly respect. My name is Valerie Suryono, a bachelor student in Electrical Engineering University of Indonesia. And in our forthcoming presentation, I will encapsulate our research findings on the design and analysis of fiber to the building for smart building implementation in Pusgiwa or Pusat Kegiatan Mahasiswa. And shortly, I'm going to explain about the data, the requirements for this building. Through our conversation or presentation, we will offer a succinct overview of the driving factors behind our design. Next. And we will introduce it through the introduction, optical network design, results and analysis, and with concluding remarks. Next. So the primary motivation for this research arises from the current digital age, where rapid technological advancements have become the norm. There is an evident and pressing need for dependable, high-speed, and seamless broadband connectivity, which holds significance across various contexts, including individuals, businesses, and also the entire community. And in this quest for robust connectivity, the adoption of smart building technologies emerge as the key strategy. However, we must acknowledge the challenge that lie ahead, encompassing the bandwidth demands and tailored infrastructure for specific application. Yet, research indicates that the most practical solution lies in the synergy of the fiber to the building, or FTTB, and also the local area network, or LAN. Next. The integration of fiber to the building and LAN offers a multitude of advantages, particularly within the context of smart buildings. FTTP networks in this setting facilitate swift and reliable connectivity, optimizing data transmission. But however, we must know that the seamless operation within a building complex necessitates an equally crucial component. Local area network or LAN planning and the combination of FTTP and LAN brings forth a plethora of benefits, including enhanced last mile connectivity, enabling a faster and more dependable broadband service for end users, and also suppressing the capabilities of copper-based wiring. Next. Therefore, our vision to establish a system encompassing fiber to the building and also LAN system for the student center or Pusat Kegiatan Mahasiswa involves a well-structured workflow as shown here. It commences with an in-depth building survey taking place right here in the very venue where I stand. And subsequently, we delve into the intricacies of network requirements. Our journey then takes us through the stage of system design and device selection, culminating in the meticulous eligibility assessment, all capped off with the comprehensive analysis incorporating design calculation. Next. Our network topology is actually depicted in the later diagram. The initial building survey, however, yields these infallible floor plans. These floor plans play a pivotal role in determining fiber optic cable lengths, cost estimation, and pinpointing the precise location where the highest bandwidth demand arise. Next. And this is our topology. To serve 400 users within a single building, necessitating a total bandwidth of 1,304.8 megabit per second. And then in this topology, we require a total of 16 optical network terminals on each floor, encompassing and installed across the floor's second floor until the 8th floors. The deployment strategical places the optical line terminal, or OLT, and also the optical distribution cabinet or ODC on the ground floor, referred as to the D floor in the aforementioned designs. In contrast, the optical distribution panel or ODP will span from floor 2nd to the 8th. Next. And this is the aforementioned bandwidth requirement. There are 3 kinds of bandwidth requirements. There's a voice, video, data, and the total is, as I have mentioned before, it encompasses almost 1,300.8 megabit per second. Next. And guided by this data, we have crafted an all-encompassing floor plan, showcasing the room destination along with the network distribution cables marked in blue. So the blue wires is actually the LAN and also the fiber to building, where in the ground floor, there is the OLT and ODC and also the ODP. Next. Now, moving forward, let's delve into the selection of devices. Our device choice will be intricately tailored to the unique floor plan condition and also room occupancy densities within the building. After some rigorous analysis and research, we have arrived to this following specification with optical fiber using single mode variant, the G652D and also the G657A2 as both the drop and feeder cable and also the patch ports. We also use the SFP, the 1000 base LX, and there's also more details in our paper that you might access in the future. Next. Now, building upon our device selection, we will assess the system sustainability by examining several key parameters, including the power link budget and also the rise time budget. This evaluation will focus on both the upstream and also downstream directions, employing the following formula, as you might see in this presentation slide. Through the calculation of fiber, splicer, and also the splitter attenuation, we can then determine the power link budget at the receiver end. And next. The same theories also applies to the second parameter, which is the rise time budget, on the next slide. Next. From this parameter calculation, we will unveil the outcome. By utilizing the provided data or the downstream and also the upstream power link budget, we arrive at values for both downstream and upstream power link budget. These values fall comfortably with the specified range for optical detector specification of OLT and ONT, which is between the negative 28 decibel mm and also the negative dBm. As a result, the power link budget parameter is successfully met. Next. Next, the rise time budget is calculated by a bit rate of 10 GB per second in downstream and side, while the upstream is also using the bit rate of 2.5 GB. It's almost the same as 5G networks. The result of these two RTP values on both sides will be used in further calculation to obtain the rise time system value. And the result indicates that the RTP system parameter is still within the rise time budget value limit for the downstream and also the upstream sides. Next. Now, there's also some potential engineering problems and solution, which in this paper, we found out that it was about the electrical interference problem and also the design based on the existing system. Regarding the electrical interference problem, there is some problem within caused by the electrical cables and also the electronic device, which can also subsequently affects the optical networks in the XG1 cables. In this, the solution proposed by our team is by the physical separation layer between the fiber to the building infrastructure and also the high photoelectrical cables. Meanwhile, for the design based on existing system caused by the system itself, we may use a total overhaul on network system that is not actually needed, and also accessing the natural quality from the bandwidth parameters that meet the standards in networks in general. Next. And also the last problem is regarding the limitation on network capacity sharing. Well, the limitation on network obviously sharing, well, the problem is in this student center building, there's also a heavy data traffic as per mentioned before. There are about 400 end user on a network that is connected to one XGPON network. And the solution is also by periodically monitoring the data traffic on the XGPON network regarding the distribution and number of users, and which by this we can determine the needs of each floor in the student center or in the Puskiwa to maximize the network capacity. And next, this is our concluding remark. In hindsight, this paper highlights the successful design of the implementation of fiber to the building, utilizing a 10 gigabit passive output network or XGPON architecture within the Puskiwa or the student center building. The system feasibility test evaluates key parameters, including the power link budget and the runtime budget. Both yields a successful result, with the power link budget result meet the requirement of a downstream value of negative 24.46 dBm and an upstream value of negative 13.06 dBm. And also with the runtime budget value of 0.0521 nanosecond, also meet the specification itself. The result indicates that the network can provide a robust internet connection which surpasses the required performance criteria, offering a bandwidth of 1,300.8 megabytes per second and suitable for accommodating a total or even more than 400 users. However, in this concluding remark, I will also mention that the further research and investigation are necessary to enhance this proof. And that is for my presentation. Thank you for listening, and I hope you have fun with this new knowledge at hand.
Okay, thank you. Thank you, Valerie, for your presentation. Any questions from the students here? We have so many students here in the classroom, Valerie, but ya bisa tanya pakai bahasa Indonesia nggak apa-apa. Nanti saya translate. Do you have any questions? No? Okay. Okay. So I have one question, Valerie. So in your research, why don't you include the budget estimation for deploying fiber network infrastructure in Student Connect, Student Center? I mean the budget. It's like in how many million rupiahs that we need to implement your design in the building.
Okay, that is actually a very interesting question because before we publish this paper, we actually include the budget estimation. However, our supervisor suggests that maybe we should need a further research to actually determine whether this budget is actually suitable, especially knowing the telecommunication devices is also pretty much, I'm not going to say that it is expensive, but the price itself is not exactly publicized, and you cannot just simply find it online. You need to make a further research. Indeed, maybe this will be a better note for us itself, that we may have to dive deeper into the feasibility studies regarding economic challenge. And I thank you for the excellent question.
Okay, thank you, Valerie. I hope your research will be implemented in Universitas Indonesia. Yeah, thank you for your presentation.
Thank you.
Okay, let's go to the next presentation. We have a presenter from India here. This paper is from Abhishek Kumar C. He will present the paper entitled Automated Formal Verification Methodology for Digital Circuits. Abhishek, are you here?
Yes.
Okay.
Yes,
Please
I can hear.
present.
Yes, a very good afternoon to everyone. So today I am going to present my paper on automated formal verification methodology for digital circuit. So I am from Department of Electrical and Electronics Engineering at Rajiv Gandhi Institute of Petroleum Technology. Next slide. Next slide. Yes, so in this paper, what we have done actually, So in this paper, what we have done, if you see that this paper is actually tell you the an innovative, just previous slide, please, abstract. Can I share my slide? If you allow me to, can I share my slides?
Do you want to share your own screen?
Yes. I
Oh,
would like
okay.
to.
Okay. Yes, you can. Yeah. Now you can share your own screen.
Is it visible?
Yeah, yeah, it's visible, but please slideshow. Yeah.
Yes.
Okay. Yeah. Good.
Thanks. So in this paper, what we have done actually, if you see that the digital circuit are susceptible to physical fault that occur at any stage of their life cycle. And that life cycle could be either during a manufacturing or during assembling, during storage or during service spaces, and many more you will see. And this digital circuit is very susceptible to the issues. And these issues is nothing but you can say these are correlated with the speed, current, voltage, and all other logical faults. So what we have done here, we have actually to identify the innovative method. In these innovative method, we can actually what we can say we have actually automate the testing. So ultimately, the overall aim of this paper is to testing the digital circuit through automation. Previously, we will see that there are a lot of method that was available, and these methods were very time consuming. And these time consuming method, that is why we have actually gone through the automation. So the proposed work we have actually see that to development of the circuit transition matrix, and through this development of circuit matrix by using quantum gates, which is a fundamental of quantum communication and quantum things, will generate an automatic test generation. This automatic test generation you will see that is ultimate aim to verify the digital circuit. So we will see how it is actually going to work. So we will see that we have shown the block diagram of the system. So in the block diagram system, you will see that if you have a circuit, say suppose you have a circuit specification, and for example, this is the example of multiplexer. And through that, we have actually generate the transition matrix, and that transition matrix is going for particular things. And after that, we actually compare whether your digital circuit is faulty or not faulty. So we will see step by step. So the algorithm is actually, you will see that here we first start and we get the input data. Based on the input number of input, n is equal to 1 and n is equal to 2, we actually do the processing. So for n is equal to 2, we have inputs. And after that, these inputs we multiply with the transition matrix gate and tensor product of input. And finally, we get the output data. In circuit transition matrix calculation flow, we will see again the same thing. We have an input vectors, tensor product of all input vectors. And we have when we multiply A into X is equal to B, X is nothing but your transition matrix. So we actually ultimately to find the circuit transition matrix. So once you find the circuit transition matrix, then we can actually get the final testing whether your digital circuit is correct or not. For example, let's say this is a simple AND gate. You just understand with simple AND gate. So for input you have basically A and B, and these input A and B can be represented using this vector. This 1 is represented as 0, 1. And this 0 is represented as 1, 0. And finally, when you multiply A into B, you will get the output in terms of A dot B. So how you can actually represent this transition matrix? So transition matrix is actually nothing but your column vectors. So for example, if you have an input A, say 0, 0, 1, 1, and input B is 0, 1, 0, 1. And when you multiply with this input A and B, you will get output something 0, 0, 0, 1. So in order to represent this things in a transition matrix, this 0 again, that similar is represented as 1 0. So this 1 0 we have represented here. Similarly, this 1 is represented as 0 1. So we have represented as 0 1 here. So based on this, we have actually get the output transition matrix. And for each gate, you can actually represent the same transition matrix. So we have done with NOT gate, AND gate, you can find OR gate, NAND gate, or any kind of gate you can actually get the transition matrix. So this is the pseudo code of algorithm that we have done. So just understood with this result, so it will be more clear to you. So for example, if you have a simple full adder, in this full adder, you have generally 3 inputs, that is A and B and C. And you have 3 inputs, but you have the output is sum and carry. So you have basically 2 outputs and 3 inputs. So overall, in order to generate the CTM, that you require actually 8 to 4 matrix. 8 is because of this 3 input, 2 to the power 3, and 4 is because of this 2 output. This is sum and carry, and that is 2 to the power 2, and this is the 4. So the total matrix, you will find that 8 into 4. So how you represent it? As very simple, this is the output matrix. So if you have A and B, you can actually calculate with respect to their input, with respect to the input, and you will find the sum and carry based on our previous knowledge. So based on that, we have actually represent this CTM as we have previously shown this matrix like this, that we have get this matrix. So similarly, you need to get this transition matrix, and you need to multiply with samples input. For example, if you want to apply input combination A is equal to 0, and C in, say, suppose C input is equal to 0 and B is equal to 1. So we can represent as 0, 0, 1, and other we have taken the samples input are 0. So when you multiply, you will get a specific matrix, that is 0, 0, 1, 0. So along with all possible combinations of input, you will get a similar kind of output matrix that we have called the output generation of using CTM. So this is my CTM, this is my input sample, and this is my output. Similarly, the same thing you can do with encoder circuit. We have a CTM and we have the input samples, and based on input samples, we get the output of the CTM. Similarly, we have also done with basics of the digital circuit, including this D flip-flop. So we have actually this output matrix, and we have sample input, and we have get the output 0, 1. So based on the input samples, you got the different output. When you multiply this CTM matrix, multiply this input sample, you will get the different outputs for each combinations. So how it is actually working, how it is actually works. So for example, if you have a basically faulty adder, one you have a faulty adder and another you have the basically the correct adder. So how you will verify that which circuit is correct or which circuit is false. So based on this, we actually in this case, in this figure, you will see the second stage and the gate connected wrongly here in this case. If you just closely correlate with these two circuits, one circuit is wrong and another circuit is correct. So based on that, you need to find the output matrix, and once you multiply this XOR gate, you will get finally the that verification matrix, and that verification matrix is similar that we have find like this. So this matrix you will get, and based on that, based on the samples, based on the input samples, you can actually get the matrix, output matrix. So based on the output matrix, you can easily convey that whether your circuit is correct or whether your circuit is false. So similarly, verification you can done by using this 2 into 1 mux. For example, there is a NOT gate, and in this faulty circuit, you will see NOT gate is missing. So in this NOT gate missing, when you compare these two correct and faulty circuit, you will get different output. Means in this case, for example, because it is not necessary that at every input you will get the, for example, this is this faulty and this is the correct circuit. So for example, if you take the input combinations, okay, take the input combination at respective, you will see the different output. So at certain inputs value, you will see the correct output of Y is different, and at certain input, your faulty circuit at different outputs. So based on that, you can actually verify whether with your circuit, your marks, or whether any kind of simple digital circuit is correct or not. So in conclusion, we have actually proposed a very simple algorithm that we have called the CTM based algorithm. So this algorithm utilized the CTM generated based on the gate information from Excel file. So we have done this all through the automatic things. By using, we actually get the, we first actually generate the CTM files, and we actually store everything into the Excel file. So we call and we get the resultant output of the circuit. So thank you. So this is the presentation from my side.
Okay, thank you. Yeah, thank you, Abhishek, for your presentation. Yeah, any questions? Ada pertanyaan? Silakan. Kuliah sistem digital berubah kayaknya. Okay, I have one question. How can we implement this automation in the digital circuit manufacturing process? Do you have any idea or recommendation?
During manufacturing, it is because during manufacturing it is not possible, because this is everything. This is the pre fabrication process. So means because this everything you need to design something through software, automatic software. So before fabrication, you need to actually verify whether your circuit is correct or not, and then you will send your circuit or your design to the particular fab for final fabrication. So
okay, so yeah, so we need to yeah, so we need to run the automation verification before we do the fabrication, right?
Yes, because this is the process flow of IC design. In IC design, first you need to you need to first design some algorithm, and based on that algorithm, you design some transistor level design. After this transistor level design, you need to actually do the verification. Once verification is completed that everything is correct, and then you will go to the fabrication. So this is the basic flow of IC design. So this is the before the IC design part, actually before the fabrication part.
Okay, thank you, Abhishek, for your presentation. I think it's very interesting research, yeah, of you. Thank you, Abhishek.
Thank you, everyone. Thank you.
Okay, we will continue to the next presentation. The paper is Federated Learning and Differential Privacy in AI-based Surveillance Systems Model. I think we have Venantius here. Are you ready to present your paper?
Can we wait a second? Sorry, can you hear me?
Yeah. We can hear you clearly.
Okay, wait a minute, please.
Do you want to present your own slide or you just this one?
No, it's fine, we can start now.
Okay, thank you.
Okay, hello everyone. My name is Venantius Reynari Tanaya. I'm here today with my partner Jason Adewijaya as representatives of our team from the School of Computer Science in Bina Nusantara University. Before we begin, I want to give many thanks to the ICTS conference for accepting our paper. In this research, we chose to dive in the world of privacy-preserving techniques and computer vision, hence the title, Federated Learning and Differential Privacy in AI-based Surveillance Systems Model. Next, please. Next, please. So for today's table of contents, we have introduction, objective and contributions, methods, results and discussions, and finally conclusion. Next. Next, Ken. Now, in today's era, technology has been rapidly growing. presenting us with endless opportunities and potential. One technology in particular has become more and more popular, being an integral tool in enhancing public safety and security, which are surveillance systems. Another technology that has been steadily gaining popularity is artificial intelligence or AI. It is not rare to see these two technologies getting combined, becoming something that is called an AI-based surveillance system. However, AI-based surveillance systems has raised significant concerns about privacy. The core of the issue lies in the massive amounts of data that are collected and analyzed, including potentially sensitive information about individuals which could be compromised. To address these concerns, many privacy-preserving techniques have emerged throughout the years. Next. Two of these privacy-preserving techniques are differential privacy and federated learning. Differential privacy provides a statistical framework that safeguards individual data points during the training process, while federated learning enables AI models to be trained on distributed data without centralizing all data in one place. We implemented these privacy-preserving techniques on a long-term recurrent convolutional network, or an LRCN model. Our study delves into the effective implementation of federated learning and differential privacy in training AI-based surveillance system, as we try to achieve a balance between maximizing privacy preservation and minimizing the negative impact on model accuracy. Our results showed a considerable trade-off between keeping data privacy and pushing model accuracy. Next. Next again. Our objectives, the objective of our research is to boost the privacy-preserving capabilities of AI-based surveillance systems to thwart the leakage of sensitive data during the model training process. And our contributions are exploration of privacy-preserving techniques, which means our study explores the implementation of FL and DP in the context of AI-based surveillance system. And then the next contributions is practical implementation and evaluation, because our study implements privacy preserving techniques on a specific model, the LRCN, which is tailored for visual recognition and description tasks involving sequential data. And finally, balancing privacy and accuracy, because our paper found that the overall accuracy of the model may decrease due to the incorporation of privacy preserving techniques, and it emphasizes the importance of achieving a trade-off between accuracy and privacy. Next, please. Now, next again. For our methods, the research steps follows quite a few steps, starting from analyzing existing projects to find out more about AI-based surveillance systems, which afterwards, then we collect the data and pre-process it to make it usable for training. We then chose a suitable model, which in this case is an LRCN model. Then we trained our model with the pre-processed data. And then we test the trained model prior to implementing any privacy-preserving techniques and evaluated the performance. After which, then we implemented the differential privacy, federated learning, and a combination of both to the model. The implementation of each method are done separately, and after implementation was done, we tested each model and evaluated the performance of each model. Finally, we analyzed the impact of the privacy-preserving techniques to the model's performance from our experiment results. Next, please. The datasets we used are the recognition of human actions dataset from KTH and the video fight detection from Kaggle. We took a combined amount 300 videos from both datasets, dividing the amount evenly between the three categories of fighting, walking, and running. Next. Now, the data preprocessing involve 4 steps, which are frame extraction, frame selection, resizing, and normalization. In the first step, the videos were processed to extract frames, converting them into a sequence of static images that captures the actions. In the second step, frame selection, we established a skip frame window based on the total number of frames and a predefined sequence length, because each video has a lot of frames. Therefore, utilizing every frame for model training would be computationally demanding. The third step is resizing. Each selected frame Each selected frame was resized to a standardized size of 64 by 64 pixels. And the final step is normalization. In this step, each frame was normalized. The process scaled the pixel values to a range between 0 and 1 to maintain consistency and uniformity. Next, please. For our chosen model, as said before, is an LRCN. LRCN combines CNNs for visual input processing and recurrent sequence models such as LSTM to generate variable length predictions. LRCN is designed specifically for visual recognition and description tasks involving sequential data. Next. For the implementation of differential privacy, we used the Adam optimizer. We set a control variable, which is the elk norm clip parameter, and then we have one independent variable, which is the noise multiplier parameter with a varying value of 0.8, 1.2, and 1.6. And then we observe three dependent variables, which are epsilon, privacy budget assuming a Poisson sampling, overall model accuracy, and the single prediction result confidence. Next. For the federated learning implementation, we utilize the TensorFlow federated framework. Our experiment is based on a simple iterative averaging process. We use stochastic gradient descent as a server-based optimizer and a client-based optimizer. In this context, the independent variable was the model weights obtained from each participating client. We have one independent variable, which is the number of devices, with the values of 10, 20, and 50. For this experiment, we observed two dependent variables, which are overall model accuracy and single prediction result and confidence. Next. For the combined implementation, we use the differential privacy aggregator provided by the TensorFlow federated framework to implement the differential privacy within the federated learning model. This aggregator applies a noise multiplier to the model weights obtained from each participating client before they are averaged. In our experiment, the noise multiplier varied with values of 0.4, 0.6, and 0.8, serving as our first independent variable, and a number of devices being the second independent variable, having the same values as the federated learning implementation from the slide before. The dependent variables observed in the experiments were also the same as the federated learning implementation, that being epsilon, overall model accuracy, and single prediction result confidence. Next, please. In this chapter, we will be discussing the results of our experiment. Next. Now, each of the methods, there were three methods, and each of them were done. The experimentation of them were done multiple times with varying values for the independent variables. Therefore, in this section, I will only be including the most optimal result from each method implementation. In the implementation of differential privacy, the most optimal result came from setting the noise multiplier as 1.2. In the federated learning implementation, the most optimal result came from having the value of number of devices 20. And finally, in the combined federated learning and differential privacy implementation, the most optimal result came from having the noise multiplier as 0.6 and number of devices as 50. Next, please. This is the comparison for each model accuracy. It's not that far off in terms of accuracy, but the original model is obviously will be the best performing one because there were no privacy preserving techniques implemented on it. And compared to the original model accuracy, the implementation of DP and FL individually resulted in reduced model accuracies of 62.66 and 68%. However, when combined, they yielded an accuracy of 69.33%. This shows the trade-off between preserving privacy of data and model performance, where implementing privacy-preserving techniques is sure to bring down the model performance. However, the combined implementation showed a good enough result considering that it has both methods implemented in it, and it only went down 7% compared to the original model. Next. Now, for the comparison of the prediction confidence, it is not too balanced. The original model by far outperforms every other model. However, despite a decrease in confidence levels with DP and FL implementations, the combined approach maintained a rather satisfactory levels across categories. These results underscore the promise of using DP and FL to balance effective surveillance with robust privacy protection. Next. Finally, conclusion. Next. We explored integration of federated learning and differential privacy in an AI model for surveillance systems activity detection and observed the trade-off between privacy preservation and model accuracy. The key points we can take from the results are, first, differential privacy implementation showed that higher noise multiplier enhanced privacy but negatively impacted model accuracy and confidence in predictions. Federated learning experiments revealed that increased number of devices led to the decreased overall accuracy and potential limitations with excessive device diversity. And third, optimal balance between privacy and performance requires careful calibration of DP's noise multiplier and determining network size in FL. Next. And the notes for future works, further optimization of both FL and DP methodologies are needed, which can be done by tweaking their parameters, such as adjusting the noise multiplier and exploring the more diverse network sizes. And alternate privacy preserving techniques like secure multi-party computation or homomorphic encryption should also be explored. And lastly, the practicality and scalability of these types of systems should be reviewed to find out if they are applicable in large-scale surveillance systems with constraints such as bandwidth, computational resources, and user privacy preferences. Next, that's all. Thank you.
Thank you very much for your presentation. Any question from the participants? No? Okay. Okay, yeah, please ask the questions finally.
Hello, I'd like to ask, thank you for the presentation. I'd like to ask something. So in the differential privacy implementation, you're using the Atom Optimizer. I'd like to ask you, if you still remember, I guess, how much learning rate that you have set for the Atom Optimizer? I guess that you're using that Keras for machine learning, if I'm not mistaken. And I would like to also ask, how does the choice of the noise of the multiplayer values of 0.8, 1.2, and 1.6 in the implementation of the differential privacy? I guess that's all my question. So firstly, I just want to ask how much learning rate that you have set for the Atom Optimizer. Thank you.
Okay, for the learning rate, I'm afraid I already forgot. I need to open the code again because I don't remember, quite frankly. And what was the second part to your question? Sorry.
I just want to ask, why are you using the 0.8 and 1.2 and 1.6 as the choice for the noise multiplier values? Because if I'm not mistaken, well, in my short experience in machine learning, when I have noises in my data, I would like to clean that noises using the Fourier transformation and etc. But why are you using that choice of noise multiplier values of 0.8, ranging from 0.8 till 1.6? Thank you.
The reason I should say we chose to use that values of noise multiplier is frankly because this experiment was done by a small team of undergraduate students, so we don't have that many computational power or resource to apply a higher noise multiplier to the model.
Okay, thank you so much for the answer.
Thank you for your question.
Okay, thank you. I think that's all, Venantius. Thank you for your presentation. I think it's quite interesting research because you combine machine learning and privacy issue in your research. Thank you, Venantius.
Thank you very much.
Okay, let's have the last presentation in this track. We have a presenter from Malaysia, Jabin Tahir. The paper is Deep Input ICTS, Enhancing Intrusion Detection Systems with Deep Learning-Based Missing Data Imputation. So, Jabin Tahir, are you ready to present your work?
Yes, thank you. Can you hear me completely?
Yeah, we can hear you clearly. Please present your paper.
Okay. Hello, everyone. I'm Najabin Tahir. I'm a PhD student in the University of Putra, Malaysia. And this is a joint work. Dr. Azizul Abdullah is my supervisor. and the two other members, Noor Azura and Dr. Khairul Azhar. They both are my committee members and we belong to the same university and the same department. Next, please. Next slide, please. Okay. The motivation behind this work is to find some anomaly detection in real-time scenarios. Like if we talk about the cybersecurity context, we now need an algorithm through which we are able to detect anomalies or intrusions in the real time, or we can say near the real time, like just like streaming algorithms, like streaming data, we are able to detect anomalies in that during that time. So the algorithm which we are trying to design is not going to be restricted only for the intrusion detection or for the cybersecurity, but like it could be for any other scenarios, like data set for the graph-based data sets, or we can use it in the in the medical field, like we can use it to diagnose any diseases. So what we are trying to do, we are working on the denial of service attacks mostly, and intrusion kinds of detect to minimize the harm, because as long as the intruder remain in the system, the chances are more that it will harm the system more. So as quickly as possible, we can detect the attacks so that we can mitigate the negative effects of that attack. As we know that we have lots of like, for example, GitHub attacks and the Twitter attacks. So these are the examples of DOS and DDoS attacks which we are focused on. Next slide, please. Like, for example, here I've taken example of a data set. Like, suppose if we have a data set and it has lots of missing values, but we have to model our machine learning model here. So what is the first question which comes to our mind after seeing such a data set which has missing? That why this missing value is here? So there are different kinds of missingness methodologies. Like if there is a certain value is missing, so we can say, if we know, or we can think it with the logic that the value is missing due to this reason. So we can call it that it is okay. But if we cannot think that why the value is missing, we can call it is completely randomly missing. So, but if we like some race is missing, or different races are there, but someone race is missing, or the gender is missing. So we have no clue sometimes that why it is missing. So if we can guess the reason, then it's okay. But if we cannot guess, that it comes into completely randomly missing. Next, we come to the not randomly missing values. Like if we just like date of hire, there's a column of date of hire in this data set, and I've just omitted two values from the above and two from the downwards. So if we can say that because of some age of the employees, they are not so much comfortable to display their date of hire. Like if we can have some logic that this is the reason that the data is missing, then it's okay. Otherwise, we do not have clue, so we are not sure that if we apply certain techniques to fill those gaps, will it be beneficial for the data set, or it will get more bad, or the output will be affected more. So these are the I say missingness methodologies which we discussed in the paper. I'm working on the anomaly detection, but when the data sets I'm working on, because as a researcher, I do not have access to someone's personal data set. So I'm using the available publicly data sets. So this is the problem which is quite common in the data sets publicly available. So let's see what are the methodologies we can apply. Next slide, please. So this is how the presentation will go. First, we discuss the problem, then the algorithm which we designed to fill those gaps. Then we discuss the methodology. What was the methodology we adopted? then how we run the experiments, what are the results, and how what the future work will be. Next slide, please. So these are the some missing values types which I've already just mentioned, that they are completely missing at random. They could be missing at random. They could not missing at random, and structure missing. When you are 100% sure that the data points are missed due to some reasons, we call it structured missing. So basically, what I'm trying to tell you here, that there are three ways, three steps to follow when we find some missing value. Like first, we find the missingness methodology. What are the, why they are missing? First question. Then we see some method, that how can we fill those gaps? Either we can use the available methodology, or are we able to implement our own our own method which can improve those methods which are already available. And third is we will evaluate that if we implemented a methodology, we are using it to fill those gaps, how they are working, because I'm using here machine learning. So the classifiers, obviously, what I'm using, they are from the machine learning classifiers. Next slide, please. So possible solutions, what are the possible solutions we have? We already have, first one is the list resolution. What is list resolution? Like, suppose if we have a data set and there is a tuple which where a certain value is missing. So what are our options here? First thing is maybe we can delete the whole tuple. So what are the advantages? The advantages are more because just by deleting the whole tuple, we can lose some important information which is written there. Or it may be possible that the value which we are ignoring or it is missed, it is more beneficial to understand the data set. Okay, so next possible solution, there could be mean, median, they are mode. Why three are written together? Because in the data sets, we have different kinds of data available. Like we have numerical data, we have discrete values, we have continuous values, we have categorical values, and in some data sets, we have all these. So how to handle those kinds of data sets? So the method is mean, like if you have only continuous value like float values, 12.5, 12.6, we can use mean there. Median is used for categorical kind of structures. Like categorical means if we have text written there, we have in numerical values written there. So what technique we are used to impute them? We can use the median. Mean, what will do? If we apply on a column mean value, obviously it will take the mean of that column and then it will fill the missing gaps. Median will take the median of that column and try to fill the gap. So there are other more sophisticated kind of solutions available like DAC imputation. So DAC imputation is computationally expensive. What does it mean by computationally expensive? Like there is hot DAC imputation and there's cold DAC imputation. In hot DAC imputation, what we do, we usually see the column, and if the values are missing, we try to look at for those values which are quite similar to those values. And we then guess the system will write the value according to the similar data available in that column. And cold data set, cold imputation, what they do, they basically imputed the value by certain technique. Like they are not going to take the values from the same data set. It will impute the value from some other data set. So this is the basic difference. And the next possible solution for imputation, it could be model-based. Like model-based, like machine learning models, like it could be, we can use KNN, K nearest neighbors, EM, expectation maximization, and there could be ML, there could be regression. These are all the possible solution of imputation technique, like expectation maximization. It is also a statistical technique, but we use it in the probabilistic environment where we want to find how much the variable two variables, one is dependent and one is independent. So mostly our target variable, we call it dependent. So how the two variables are have relationship between them, how much they are connected to each other. Through probability, we find the value, which is very common in statistical technique. It's a very common statistical technique. In regression, we know regression is also, we call that we find that how much certain variables are dependent on each other. So we want to find some value. So these are some possible solution. And next slide. So what we are doing here and what's the gap there in those techniques? Actually, here we are trying to control these missing values in a controlled fashion. Like in a controlled fashion means that what we are trying to do, we are trying to put the missing values equally so that we can get a better understanding of the data set. Why? Just to compare it with the other tools available. As I've already mentioned, there are other tools available and those tools have different procedures to fill those gaps. So what we are doing here, we are trying to fill the gaps in a controlled fashion. And first we try to make sure that the missing values which are there in the data set should be equally balanced so that we can compare the technique with other techniques. So what we are doing here, like suppose I selected 3 columns from data set of 100 features. We have 100 columns and I've selected 3 columns from it. Now, what value I want to put in those columns? Like suppose I put 100. So how the algorithm will distribute it? The algorithm distribute it by taking the approximate values. It will take 33%. It will put on these those missing values filled by 100 with 33%. It means it does not going to fill or refill those values which are already written. It will just select those columns which have missing values and write 33% of those of the value of 100 because we have to write 100. Now, how many they have distributed? 33%. So suppose if we are divided with a certain value and the remainder 1 is due, then of course we are going to add 1 more column. So if like 22.5 is coming, so we take 23. So 23% will be written. Next slide, please. So what are the method? This is the algorithm. RMV is the algorithm to put the missing values in a controlled fashion. Then how we are going to impute it? Where we have used, as we know that first we have to load the data. The method will be same. We have to pre-process the data set. It depends on the data set, what you are using. As I told you, as a researcher, I do not have access to someone else's private copyrighted data. So I'm using publicly available data set. Then autoencoder, I've used autoencoder, but specifically I use stacked denoising autoencoder here. The reason why I'm using, I will let you know. Then when we did the data splitting, why we do this data splitting? Because whenever we apply some machine learning algorithm, first we have to divide our data set into training and the testing. And then we do the classification, and after that we evaluate it, and then we do our analysis. Next. So after performing our pre-processing, how we did the pre-processing? Pre-processing is done because our data set is a combination of text and the numeric values and the float values. So here, first I separate the values, the numeric values, and applied the normalization. And to the categorical values, I applied one hot encoding, because one hot encoding method we used to convert the text into integer numbers. Because why we are doing it? Because the autoencoders through which we are training it, to train the data set, they need some sort of specific kind of data set, like it cannot read the text. So we have to convert it first. So after doing these steps, the complexity which we get is O(n) log n. It's space complexity of O(n). Next slide, please.
Your time's up, but could you please speed up your presentation?
we have used these data sets and next slide, please.
Yeah,
Next slide.
could you please speed up your presentation?
Yeah, so this is the performance metrics which we got. Like I've told you that I did the classification on logistic regression, decision tree, random forest, SVM. Now these classifiers give different results. Sometimes better before imputation, and some after giving better performance after fixing missing values. The reason is because it has some class imbalance issues. Because I perform my experiments on specific numbers of data set. Like for NSL, I took 14,000 samples, and NB15, NB15 data set, I took 10,000 data samples. So due to class imbalances, these classifiers get biased, and these give sometimes biased results. Next slide, please. So here, some classifiers, after applying our data set on classifiers, after fixing missing values, some performing are better, like STM and KN. And the uppers are get either degraded the performance, or it has improved, or it get biased. Next slide. So future work is that we are going to class imbalance challenges, work on this and explore strategies for how we can improve the performance and on the imputation techniques. And also we have to do some more comparative analysis. So conclusion is, next slide. Conclusion is that we have done with the multi-stage imputation process and which is handled effectively missing data, and the random missing value algorithm, which is tool to produce missing values in data set randomly. Okay, thank you. And our data is publicly available on the GitHub, my algorithm.
Okay, thank you.
Okay, thank you then.
Yeah, thank you for your presentation. Now we go to question and answer session. Do you have any questions from the participants? Okay, so I have one question. Like you explained before, that we have several methods for missing data imputation. So what is the advantages of deep learning based method for missing data imputation?
The advantages is because through deep learning, like autoencoder we basically use, they are very deeply understand the data patterns. And we use deep learning methods because we want to reduce the dimensionality, because the data sets are very huge and the number of columns are huge, number of rows are huge. So we want to reduce the dimensionality, as well as we want some technique that we are able to learn the data patterns more efficiently.
Okay. Oh yeah. Okay. Thank you, Mas Jabin Tahir, for your presentation. Okay, now we reach the end of this parallel session. Thank you for online presenter. You can go back to the main Zoom meeting to have a closing ceremony for ICTS conference. For online participants, you can go back to the main Zoom meeting. And everyone here, thank you for coming in this parallel session. You can bisa ke aula untuk closing ceremony. Yeah. Okay, thank you everyone for coming. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you.